Okay, few more things for factorial designs, particularly with a focus again on the unbalanced cases. When we have sums of squares for contrast, they are always, for any scenario, type 3. If your contrast is built for all G treatments, that's fine. And if your contrast is just for the row effects or the column effects or another set of parameters, bear in mind that this implies equal weighting across the factors that is not really occurring in the contrast, or this might or might not be something that you think is appropriate. Okay, so just keep that in mind. Again, I think with our in-class work, we'll hopefully investigate this a little bit more. In summary of all of this sorted material we've gone through, in balanced data, we don't talk about type 1, type 2, and type 3 sums of squares. And the reason why we do not is because there's no such thing as different types of sum of squares. They're all the same. Okay, so for balanced data, contrast coming from different standard terms in the model or orthogonal. So order doesn't matter. Okay, the order in which the model is built. The lack of balance breaks orthogonality, and that is the root of the problem, what creates this whole big mess that we've been sorting through and will sort through in class this week. Things really get crazy and difficult when one or more of the treatment counts is 0, and this is particularly chosen in that in-class example that we do on the gender and education pay rate example. So even when we have a case where one of those replications is 0, where we have no that particular combination of the factorial treatment levels, then even if you choose a parameterization and weighting scheme, the empty cells mean that your parameters are not going to be well defined. And so type 1 and type 2 analyses are going to be appropriate in this case, whereas type 3 is just not. I hardly think about using type 3 except in the context of those contrasts because I just have more times that type 1 and type 2 are suitable. Your best bet, though, in these kinds of cases is to choose a set of contrasts among the cells where you do have data and just work with those.